founded LittleHorse because the job of a software engineer is actually getting harder. So, we have to build applications that orchestrate business processes across various microservices, legacy systems, mainframes, external APIs, and humans. And this means that whether we like it or not, we're actually all distributed systems engineers. And we all know distributed systems are hard. And that's because networks fail, external events don't come back in, servers crash, and all manner of things actually can go wrong at the business process level once you get beyond making sure that your technical processes are actually reliable. And that's exactly why I founded LittleHorse. LittleHorse is a workflow engine that allows you to easily and reliably orchestrate business processes across all of your existing systems. And how does that work? Well, take a look. So the first thing you need to do in order to use a workflow engine is define your workflow specification. And we see here we've defined a workflow where we first charge the customer's credit card and then we ship an item to them. And LittleHorse will be responsible for orchestrating the entire process and making sure that it happens. And we don't have any customers who call us angrily because their credit card was charged, but they didn't actually receive their order. So on the bottom, we'll see we have a LittleHorse cluster deployed and 2 task workers, which are responsible for actually executing the work. So when we tell LittleHorse to run the workflow, LittleHorse will create a workflow instance. And LittleHorse will advance the workflow instance to the first node in the workflow, which is the charge credit card node. And LittleHorse will put a task on a task queue that a group of payment workers or a group of task workers are listening to, and it will tell one of the payment workers, hey, please execute the charge credit card task. And now the payments worker might, make a call to a Stripe API, or it might execute a mainframe routine or something like that, and then it will tell the LittleHorse server that the task has been successfully completed. LittleHorse will consult the workflow specification again and determine what is the next step for this workflow instance and move on to the ship item node. When this happens, LittleHorse will dispatch a task to the shipping microservice and tell the shipping task worker, hey, it's time to execute the ship item task. And shipping worker will think about it for a minute, and when it's done, tell LittleHorse that the task has been completed, and LittleHorse will advance the workflow to the next step, which is that it's actually done. Well, there's 3 great things about this. So in LittleHorse specifically, first thing I'd like to point out is that workflows are defined in code, and your tasks are also in code. This means you have version control. It's very lightweight. You can use plain vanilla tooling that you've used your entire life as a software developer. And it's also very easy to evolve. And it's a lot more lightweight to learn than legacy BPM systems or BPMN-based systems. And secondly, I'd like to point out that because the task worker is just code, and you can do anything with a task worker, you can integrate with any system. You can integrate with external APIs. You can integrate with databases. You can integrate with SaaS providers. You can integrate with your microservices, and you can easily take any existing code that you have and easily repurpose it into being a LittleHorse task worker. And finally, because LittleHorse is responsible for executing your business processes, you don't really need to worry about stuff like retries, timeouts, dead letter queues, the transaction lockbox pattern, Saga patterns, because all of that is incredibly easy to model inside your workflow specification. So curious to learn more and how you can make your job a little bit easier as a software engineer and get that promotion? Well, join our Slack community and give our quick starts a whirl. We'll be here to help you. May the force be with you.